data. That's wherein we talk about different types of plots. Then we're actually gonna go through them one by one. So here we have your multiple data sets in one plot. So we have already went through this, but then I just felt the need to actually just dive in deeper into this to just try and understand how you could actually plot different types of graphs in one place. And also when you're plotting different types of graphs in one place, what types of amendments you could actually make within your graphs so that they could actually make sense. What types of things that you could actually play around in terms of your plots. So I'm just gonna go ahead and create. So sorry, can you guys hear me?
Yes, it's clear.
So I'm just gonna go ahead and just create a function. So creating a function, I'm just gonna use the random normal. So there are different types of normal distributions that you would actually come across within statistics, wherein we're talking about. But now today we're only gonna be focusing on your bivariate random distribution, or rather the multivariate random distribution, which actually talks through two different types of data sets that are actually independent and both follow a random normal distribution. So I'm just going to define the first one, which is going to be x, assigning it the random normal R normal, which is a random normal. And the random normal takes into account different data sets that you actually want to extract your normal distribution from, wherein you could actually say n or rather any other letter that will actually identify the data sets that you would actually want to that you would actually want the random to actually picking the numbers. And it also takes into account the mean as well as the standard deviation. And speaking of the mean as well as the standard deviation, by default, as you could see how it had actually here, it has actually given me a suggestion. By default, our mean, if we don't identify, our mean will be assigned a 0, and our standard deviation will be given will be assigned 1. And if you could think about it, a normal distribution would be like in a form of like a bell shaped in a way, wherein you would have your negative sides on your left hand side and the right hand and the positives on your right hand side. So with you not assigning anything on it, by default, when it's actually plotting, it will actually give you a mean of 0 and a standard deviation of 1. But we will actually define that standard deviation would be equals to 5, and then would want our mean to be it's actually giving us suggestions already. Our mean to be 20, and would also come here and define our y, which is also a random independent variable from the y side, from x, sorry, multiplied by the function of x, subtract 1.0 plus R normal, because we want it to be a normal distribution. R normal 10, standard deviation equals to 9, and it's going to give the mean by default, letting it being 0. And we'll actually run this. And just to test probably maybe the correlation in between the two variables, to see the relationship in between the two of them. We have quite a very strong correlation between the two data sets, which actually giving us a clear indication that both of them, they actually follow a normal distribution, and them following a normal distribution, they're quite independent from each other, as you could see from the formula itself then. And it's very important to actually note that if I could go back now and run, like, keep in mind that we've got this correlation, right, of 0.85. So if you run this again, run there, you'll see that the correlation had actually changed, right? simply because we actually picking numbers randomly. It's more or less the same as your random in between, probably in Excel. If you're looking at a random in between 5 and 10, right? And then you're looking at every time you actually click on that formula, it actually gonna generate the figures randomly. So these figures change at almost all the time because it's actually picking the figures randomly. But then we've actually assigned it to pick 10 figures with a standard deviation of 5, the mean of 20, and then on the second equation we have um, that um, our standard deviation of 9, and then a default mean of 0. All right, so I'm just gonna go ahead and plot this same way that we're actually doing a simple plot. Just gonna plot the value of x, the value of y, and then we're just gonna give it the x label. Nothing has actually changed here. We're just gonna give this independent variable, the y label. Just gonna the y label, I'm just gonna give it the dependent at all times, and then we're just gonna introduce the main, and we know that main would actually be the head, the heading of our graph, and I'm just gonna call it random distribution. So by plotting this already, we have randomized values that actually starting on the right hand side here. You could actually see the plot that we've actually done. So it's actually plotting the random figures, the value of x and the value of y being random between the two of them.